Let's solve some fun equations. Keep in mind that I would like your answers written in set notation because we might have some extraneous solutions from time to time with these because of our restrictions when we're taking even roots of certain kinds of numbers. So number one, we have the cube root of x minus 4 equals 0. So of course the first thing we're going to do is add 4 to the other side. So we have the cube root of x is equal to 4. So to get rid of a cube root, all you have to do is cube both sides. So this is going to give you x is equal to 64. There are no restrictions on taking a cube root, so our only answer is 64, and you are done with that example. This next problem, first thing you're going to do is subtract the 5. So we're going to have negative 4th root of x is equal to a negative 5. Luckily, we have this negative that we need to divide by, so that's just going to make this problem as the 4th root of x is equal to 5. Because remember, when we are taking 4th roots, they have to be positive or 0. So let's get rid of the 4th root by taking the 4th power of both sides, and you're going to end up with 625. No restrictions, no big deal. You're done. When we get to questions like 3 and 4, like we have a 3/2 power and a 4/3 power, then we're going to need to be careful again of what kind of root we're taking. So remember, 2/3, 3/4, 3/2, those are all roots of some sort. So the first thing we need to do in number 3 is divide by 2. That'll give us x to the 3/2 is equal to 125. So what do we do from here? Well, we can raise both sides to the reciprocal power. So we're going to raise both sides to the 2/3 power. Now if you think about that, that is x is equal to the cubed root of 125 squared. So with that, you know that you're taking an odd root. So it is allowed in this situation. If that was a negative, it would be okay because first of all, the negative would be squared. And second, since you're going to be cube rooting it, you can take the cube root of a negative anyway. We don't have to worry about this situation here. So all we just have to do is take the cube root of 125 and square it, which is going to give us x is equal to 25. So our answer is just 25. Number 4, same type of problem. First divide by 3, and you get x to the 4/3 is equal to 81. Then we're going to raise both sides to the 3/4 power. And again, you're taking an even root, but it is a positive number, so we don't have any restrictions here. Now you can do this by hand. You can use your graphing calculator to see if you get a nice number. If you type 81 raised to the 3/4 power in your calculator, you will get your answer of 27. Now if you had a decimal, then you would need to show the work by hand. And remember, there's a couple of ways you can do that. One way you can do it is just change 81 to 3 to the 4th power, raised to the 3/4 power, and then of course you would get those to cancel and you would just end up with 3 cubed, which is 27. But always use your calculator first to see if you get a nice number. Moving on to question number 5 and 6. The first thing you need to do with question number 5 is get the radical by itself. So you have 4x minus 7 is equal to 3 after you subtract the 2. And now you need to square both sides to get rid of the square root. So you're going to square this side and you're going to square that side. That's going to leave you with 4x minus 7 is equal to 9. And now you just continue solving like any other old school equation. Add 7 to both sides, so 4x is equal to 16, so x is equal to 4. No restrictions on 4 when you substitute that back into your radical. So your solution is 4. Number 6. This one's a little different. Because you just have 2 radicals on the left, what you want to do is you want to move the radical, or the second radical, to the right. So we're going to have the square root of 3x plus 2 is equal to 2 root x. To get rid of square roots, we square both sides. So this side is just going to turn into 3x plus 2. And we're squaring both terms here, so this is going to turn into 4x. Now we just solve, subtract 3x from both sides, and we get x is equal to 2. And, of course, check for restrictions. We can take the square root of 2. We can take the square root of 8. So we're finalized here, and we have our solution of 2. All right? So the first 6 examples, we had nothing funny happen. So let's go do a couple examples where something funny could possibly happen. In this first example, if we were to square both sides here, we're going to get x is equal to a positive 1. So, is that true? Well, possibly. But let's plug this 1 back into the original equation and see what happens. So, the square root of 1 is equal to negative 1. 1 equals negative 1. That's false. Now, we weren't solving for x there. That wasn't a plus or minus type thing. We just substituted 1 back into the equation, and we got 1 equals a negative 1. So that is a false statement. So that means that we have no solution with an extraneous solution of 1, because 1 is what we got when we solved, but it doesn't work if we substitute it back into the original equation. All right? Number 8 is similar. To get rid of this square root, we need to square both sides, and I mean you have to square both sides, not just individual terms. So x minus 4 squared is going to turn into x squared minus 8x plus 16, and that's equal to 2x. So subtract the 2x, you get x squared minus 10x plus 16 equals 0. Factor x minus 8 and x minus 2. So you get x is equal to 8 and 2. So you've got to think about this for a second and see what works and what doesn't work. And that, what you need to do is substitute back into the original equation. So let's do that. Let's substitute 8 back into the original equation first. That's going to give us 8 minus 4 is equal to the square root of 2 times 8. So 8 minus 4 is equal to the square root of 16, which is 4. So the 8 definitely works. Now we have to try the 2. So if we substitute in the 2, we get 2 minus 4 is equal to the square root of 2 times 2. And we get a negative 2 is equal to the square root of 4 is 2. And a negative 2 cannot equal a positive 2. So 2 is your extraneous solution. All right, so you've got to make sure when you're solving that you check for extraneous solutions. Same example, number 9. We're going to square both sides. That's going to give us x squared plus 4x plus 4 is equal to 2x plus 28. Get everything over on one side, and we're going to have x squared plus 2x minus 24 equals 0, which is x plus 6, and x minus 4 equals 0. So x is equal to a negative 6 and a positive 4. So I want you to check. So pause the video and you tell me what the final answer is. And if you came up with a solution of 4 and an extraneous solution of a negative 6, you are good to go. This is Longo and I'm out. See you, bye.